Okay, so as I said, guys, this is Introduction to Computing, Section C. My name is Mohammed Al Jaffer, and the course web page is available on your Brightspace. So today, before we get started to the lecture, to the actual content of the material, I'm gonna go over some logistics and regulations of the course. So we will be at the same page, and nobody will ask me later on, okay, why there is no a live lecture on this time, or where is the lab, or because I clearly mentioned that the lab will start next week, but I have received some emails from you guys stating that we did not receive the link for the lab. Okay. Now for the office hours, I'm gonna post them next week. So if you have any questions regarding the material, you can access me at the office hours as well as on Brightspace at the miscellaneous forum. I allowed anonymous posting, so don't worry, your name will not be revealed. However, for the assignments and the labs, your name will be there, okay? Will be shown there. Okay, so for the lectures, it's highly recommended that you attend the lectures synchronously. Once we have a live lectures, I really encourage you to attend the lectures, not to watch the recording. When it comes to attendance, I'm not gonna take attendance. However, I need to follow the lead professor, who is Professor Vida, regarding the the grade breakdown. However, in these sections, I'm gonna give a pop-up bonus quizzes. So I'm gonna give about 10%, and those 10% will be bonus to your overall grade. And it will be what? It will be taking a place randomly, okay? So you will not be notified. So I'm going to start the lecture and I will say, okay, we have a quiz now. You have 10 minutes to finish it, okay? Now, when it comes to the labs are going to be given virtual, because basically this is a programming course, and you can do all of the exercises, at your place. However, you need to attend the labs, okay? Because once you attend the lab, you get half of the grade, okay? And once you finish all the exercises, you get the full grade, all right? Okay, so, if you go to Brightspace right now, you will see that I already posted the course outline, as well as the main learning objective for this course, as well as you will see a tab for the discussion forum. So I want all of you to subscribe there. If anybody has questions regarding the assignments and I answered it, or the TAs answered it, everybody will get the answer. So you will not repost the answer, the same question again. When it comes to the assignments, the assignment will be posted on Brightspace, as well as the submission of the assignments will be posted on Brightspace. So you need to learn how to interact with Brightspace, as well as how to how to submit the assignment on time. And you need to play with Brightspace, so you'll know each module and how to to interact with it. So for the test will take place over Brightspace, so will not be in campus for the tests. They will not be the way that I organize the course. The test will take place over the quiz module of Brightspace, and it's gonna be a hybrid, multiple choice, as well as some programming exercises. All right. Okay. So for the text box, it's highly recommended to have the text box, but what I'm gonna do is I'm gonna try my best to cover everything in my slides. So in order to what is the reference book for this course is the Introduction to Computing using Python. It's the second edition. It's available as a printed version on the URL bookstore, or you can buy it directly from Willy, from the publisher itself. I'm not gonna say it. If you just search on the internet, you can you can find it. But this is against the ethical approach for copyright act. But you know what? I am my highest priority is you rather than the those rules. Okay. Now, when it comes to to other book, if you go to Brightspace, Python resources, you will see that I have posted some free books, as well as here you can go and find an interactive version of some books. So if you have any questions that that was ambiguous to you, or if you did not comprehend some area of this course in a good way, you can go and read it at your own pace. Okay. Now, as well as I'm gonna show you after, I have a supplementary courses that are available on Coursera. What I'm gonna do is I'm gonna follow these courses. So if I am a bad teacher, the University of Toronto, they're not bad. So both of us, we'll make sure that the message and the learning objectives of this course are delivered to you guys, and you are ready to get a straight A. Okay. Now, so the labs will take place by over Zoom. The TA will give you an introduction about the lab, the main exercises, a quick overview and revision about the tasks and exercises needed to be implemented. And you need to show your work to the TA at the end of the lab session, so you will get the full mark. So the grading for the lab will done immediately. Okay. Labs will start next week, okay? So this week, there is no labs whatsoever. Now, as I told you, we will have up to 11 labs, and the labs are very important module for this course in order to what? In order to deploy the objectives that you have learned in this course, as well as to break the border between you and the fear from programming language. I know most of you, they're not from a computer science or computer engineering background, so the labs are the best way to practice and keep practicing, so you will master the programming in Python. Okay. So all the labs will take place using Python 3. There is two more versions, two common version of Python 2 and Python 3. We're gonna use Python 3. Okay. And at the first lab, there will be a brief tutorial to show you how to submit the assignment, and that assignment will worth 0, okay? But the purpose of that is to practice how to interact with Brightspace and how to submit the assignment on time, all right? Now, so for the assignment, we will have 6 assignments. All the assignments will be based on programming in Python, so you don't need to prepare a report for the assignment. And you will learn how to submit the assignment on Lab 0, okay? Now, I really urge you guys, if I am the only professor at this this course, I'm gonna be flexible. I will have, some flexible policy when grading your assignment. But what I'm gonna do is, if you did not submit the assignment by the first day, you will get 20%. Second day, 30%. Third day, 40%, and after that you will get 0. So please respect the assignment. We will have 3 tests in the course. There will be no midterm, no final exam. All the tests will be like involving programming, and will test your your critical thinking. It's like, I'm not gonna test how professional you are in Python. Rather than I'm gonna test how did you comprehend the concept that I've explained in this course. Okay, so for the breakdown of your final grade, here it's shown. So we will have 11 labs. Okay, each lab has like a 0.5%. So collectively we will have 5%, 6 assignment, and the breakdown for the exams are equally divided to 20%. Now, in addition to that, for this sections, there will be a 10% for pop-up quizzes. It's not mandatory to have the pop-up quizzes, but if you would like to boost your grade, I really encourage you to do so. Okay. Now, those are the deadlines. So like I told you, I want to be like at the same page with you. So it will clear any ambiguity. And I would like you to respect those deadlines, And when it comes to the tests, the first test will take place on the 16th of October. The second will take place at Saturday, the 13th of November. And the last test will take place during our last lecture, which is Tuesday. There is a typo in Brightspace, which is, like I said, Wednesday, but it's Tuesday, the 7th of December, during our class time. All right. So now, in order to communicate with me, I'm really sorry, guys. I do have almost 250 students in this course, and I do have my other work, So please don't get offended if I did not answer your emails, okay? So all the questions, but however, I want to make sure that I will keep the communication channel active between me and you. So all the questions that you may have, or all the questions that may raise for this course, can be asked through the discussion forum on Brightspace, okay? You can ask it anonymously, and I'm gonna answer it so quickly. So if if the same student has the same questions, there's no need for me to re-answer the question again, okay? And you can ask me questions during the lecture time, as well as at the end of the lecture, as well as during my Zoom office hours. All right. Now, so when it comes to the course policy, now missing tests, you will get a 0, okay? Unless you have a valid excuse. A valid excuse means that you're sick, okay? That's it. If you're telling me that you're traveling, you're working, you misunderstood your timetable, those are not a valid excuse for me. So please, save your time and do not contact me for these excuses. Now, for the assignment, as I told you, I'm gonna adapt an elastic policy with you, but I'm gonna take the ball will be at your court. So I'm gonna take some percentage as a late penalties for the submission of your assignment up to 3 days. After that, you will get 0. For the labs, you have to you have to attend the labs in order to get the grade. Okay. Now I said here, just just on the contract that all the deadlines are drop deadlines, but in real life, I can be more elastic with you. So please, I would like to help you as much as I can, but don't cross the line between me and you. Okay, now let's talk about plagiarism. So plagiarism means that you're copying somebody's work, and this is considered a fraud, according to the University of Ottawa Regulation 14, okay? Now, in order to avoid that, so please do not look at your classmate like a code, or do not like copy some of the code. Try to solve all the assignment by yourself. Try to solve all the labs by yourself. In case you have, some difficulties understanding, post them on a Brightspace. Ask the TAs during, the the lab times, as well as don't go to Course Hero and check website and try to post the questions there, because Professor Vida, me myself, I'm not gonna bother and follow you guys, but Professor Vida, she's the lead professor and she's very obsessed regarding this point. So please don't do it. Okay, so what I'm gonna for those coming 3 slides, I'm gonna let you read them at your own time. But the academic fraud is, claiming that a work that has been submitted by you is your work, meanwhile it's another work, or you fail to cite, the resources that, sometimes maybe I will give you a questions that is implemented on Java, and you did your homework and you converted to Python, but you did not cite the course, so you did not cite that solution, so you will get 0 for that. So please take academic integrity and plagiarism as serious as you can. When it comes to the exam, please do not, guys, do not do a Discord server and try to broadcast the questions among you, because as I mentioned, all the TAs as well as the lead professors are watching you. Okay. All right. So for these slides, I want you to read them by yourself. I'm not gonna go over them. Okay. And just to let you know that each time you submit your assignments, the TA will run it through a plagiarism software and will show the similarities between you and your classmates. So please do not copy the solution from your classmate. Try to comprehend the concept and apply it yourself. And you need to practice in order, I can watch multiple videos of how to drive, but if I did not practice, I will never know how to drive. So I want you to practice in order to be a good and an excellent developer. Okay, so when it comes to the faculty regulations, please pay attention to the the important academic dates and deadline. If you would like to withdraw from the course, pay attention to the time that to those deadlines, if you want to get the full reimbursement, or if you don't want to get enough grades, so go to this link, so you will be familiar with that. For this course, you have to get, because most of you are first year's students, you have to get D in order to pass the course. So E is not E is still you're within the failing rate. And to familiarize yourself about the policies and regulation of the University of Ottawa, I really recommend you going and you consulting this link. Okay, so I've been talking about rules and regulation, but what are my recommendation and my suggestion to you guys in order to to have an easy course with me and to get a straight A? So you need to have a calendar and to check your lab schedule. We will have a lab every week, okay? And you need to be familiar with the Brightspace. If you are in China and they're they're blocking Brightspace, you need to have a way to to bypass that using VPN for sure. And You have to be like, engaged with the material posted in Brightspace, as well as you have to subscribe for the, the discussion forums there, and to read my announcement there. Because as you can see, I would rather to broadcast my message to everybody rather than to talk one-to-one. Install Python 3.7 or 4. I'm going to show you how to install Python. Python is the environment that we're going to use, to deploy the solution for the engineering problems that we will try to solve. And some of you maybe they're better programmers than me. They're familiar with Google Colab or Jupyter, Anaconda. So we will go over how to how to work with the with the IDE which is the interactive development environment. Okay, so general suggestion. Okay, so please stay engaged. Don't say that, okay, I'm a smart guy, I'm gonna leave all the lectures. The lectures are recorded. I'm gonna watch them once, and then then I will catch up to the course. Please take this course seriously. If you are a full-time worker, try to prioritize your work. You have to take the university seriously, and actually you have to apply critical thinking. Sometimes I will ask you some questions, and those questions, they once you have a common sense, you will find the solution right away. For the multiple choice questions, there will be 3 answers that are utterly wrong, and there will be 2 answers that looks to be the correct answer, but one of them is the correct answer. So critical thinking is one of the critical thinking and time management is one of the key skills in this course. Okay, now so to wrap it up, so don't fall behind. Try to program all the exercises or from the textbook, the assignment as much as possible. After the class, try to run the code yourself. Try to I'm gonna show you there is something called Python visualizer, so you can play with your code, change the variables, see what will happen. Oh, that's from old, old school from the previous time when it was on campus. So everybody has a laptop right now. Don't afraid to make mistakes. Nobody is complete and and is perfect in this world. So I myself, I didn't know how to program until until I start teaching programming 7 years ago. Read the textbook, or you guys you're from the digital era, so you can watch videos. But I'm gonna show you how to enroll on the 2 courses. They're highly recommended. They will they will compensate any terminology we missed, or you did not understand on the from the course, and make use of the office hours, because I'm not gonna I'm gonna give you 1 hour. I will be waiting for you. So please make sure to attend the office hours for me as well as the TAs. I'm gonna try to distribute them so we'll cover all the week. Okay. All right. So now let's say that you still need some extra help. Okay. So don't hire a mentor for this course. It's gonna cost you some money, and you need to save this money to do something else. Okay. However, at the university, there is something called the Mentor Center. This Mentor Center is designed to complement the tutorials as well as the office hours. They will teach you how to to master some learning objective of the course, and will help you meeting other students. And it's not an academic fraud to to do a teamwork thinking and a teamwork solving for the problems. However, the way that you're gonna submit your assignment, it has to be distinguished from the others, okay? And there will be also like some workshop regarding the time management, as well as if you have some kind of I'm sorry to say that, like, I have passed through those like hard time myself, like stress and anxiety or depression. So don't keep it to yourself. Try to to make it louder, so like you'll feel better. Like when it comes to mental health, the first medication is talking. Okay. All right. So why we're here? So every scientist and engineer must know some programming. So now we're living in the era, guys, like your youngest brother has a TikTok. They know how to interact with iPads, the laptops, the phones, So like softwares are becoming prominent and dominant in our life. Like back in the in the 80s and the 90s, when we have a problem and we try to solve it, they will try to solve it using the mathematical way. Like, they will try to convert the problem to a mathematical equation, try to solve it and give you the solution. Like, for instance, I'm going to ask you what it will be the time to fill, the tank, given that, the filling rate is equal to 10 drops per second or something like that. Like they used to solve it using a mathematical or differential equations, but now we can do it, guys, using what? Using using a simple computer, like a simple program. As a matter of fact, all the AI and the machine learning now, they used to be a mathematical models developed like 150 years ago, and they converted to an algorithm as well as like a program, and now they are deploying it to analyze big data and get a semantic and recommended information for you guys. Okay, now I would like you okay, I'm gonna show you this video. This is an interesting video, why we are here.
I was 13 when I first got access to a computer. My parents bought me a Macintosh in 1984 when I was 8 years old. I was in 6th grade.
I learned to code in college, freshman year, first semester, intro to computer science.
I wrote a program to play tic-tac-toe.
I think it was pretty humble beginnings. I think the first program I wrote asked things like, what's your favorite color? Or how old are you?
I first learned how to make a green circle and a red square appear on the screen.
The first time I actually had something come up and say, hello, world. And I made a computer do that. It was just astonishing.
Learning how to program didn't start off as wanting to learn all of computer science or trying to master this discipline or anything like that. It just started off because I wanted to do this one simple thing. I wanted to make something that was fun for myself and my sisters. And I wrote this little program and then basically just add a little bit to it. And then when I needed to learn something new, I looked it up either in a book or on the internet and then added a little bit to it.
It's really not unlike kind of playing an instrument or something, or playing a sport. It starts out being very intimidating, but you kind of get the hang of it over time.
Coding is something that can be learned. And I know it can be intimidating. A lot of things are intimidating, but what isn't?
A lot of the coding that people do is actually fairly simple. It's more about the process of breaking down problems than sort of coming up with complicated algorithms as people traditionally think about it.
You don't have to be a genius to know how to code. You need to be determined.
Addition, subtraction, that's about it.
You should probably know your multiplication tables.
You don't have to be a genius to code. You have to be a genius to read.
Even if you want to become a race car driver or play baseball, or build a house, and all of these things have been turned upside down by software.
What it is computers are everywhere. You want to work in agriculture? Do you want to work in entertainment? Do you want to work in manufacturing? It's just all over.
Here we are, 2013. We all depend on technology to communicate, to bank, information, and none of us know how to read and write code.
When I was in school, I was in this after-school group called the Whiz Kids. And when people found out, they laughed at me and, all these things. And I'm like, man, I don't care. I think it's cool. And, I'm learning a lot. And some of my friends have jobs.
Our policy is literally to hire as many talented engineers as we can find. The whole limit in the system is just that there just aren't enough people who are trained and have these skills today.
The very best people, we try to make the office as awesome as possible.
We have a fantastic chef,
Free food,
breakfast, lunch, and dinner.
free laundry.
Snacks, even places to play and video games and scooters. There's all these kind of interesting things around the office, places where people can play or relax, or go to think or play music or be creative.
Whether you're trying to make a lot of money or whether you just want to change the world, computer programming is an incredibly empowering skill to learn.
I think if someone had told me that software is really about humanity, that it's really about helping people by using computer technology, it would have changed my outlook a lot earlier.
To be able to actually come up with an idea and then see it in your hands and then be able to press a button and have it be in millions of people's hands. I think we're the first generation in the world that's really ever had that kind of experience.
Just to think that you can start something in your college dorm room and you can have a set of people who haven't built a big company before come together and build something that a billion people use as part of their daily lives is just crazy to think about, right? It's humbling and it's amazing.
The programmers of tomorrow are the wizards of the future. You're going to look like you have magic powers compared to everybody else.
It's amazing. I think it's the closest thing we have to a superpower.
Great coders are today's rock stars. That's it.
All right, guys. As you've seen, it's not a rocket science. It's based on cumulative knowledge. So what you have to do is practice whatever you've learned. Try to consider it as a game, and increase your skills. That's it. That's all. All right. So now let's get started on the actual material of this course. As we said, that this course is called Introduction to Computing. So first of all, what's a computer? The main component of the computer. Okay, I'm really sorry. So the computer can be divided into hardware as well as software. When it comes to the hardware, those are the physical devices that make up the computer. So computer is a system composed of several physical components that harmonically working together. So these are the more the common elements of the computer. So the heart of the computer is the CPU, which is called the central processing unit. It's like the brain in the human. So it's the most important component. Without it, you cannot run a software. And back in the 70s, the CPU used to be a huge device. It used to fill up the room. However, with technologies, with the advanced manufacturing in semiconductors, we're talking about transistors. Okay, When we're talking about transistors now, they are building the transistors in a nanometers technology. So your phone now, and now if you have an Apple phone, is built on the 7 nanometer technology. That means there are about billions of transistors are stored on the, like are manufactures on that chip. And the transistors are switches. So they're like, there can be either like open or closed. So another way, they can understand binary. Binary means 1 or zeros. So the combinations of ones and zeros will create something called instructions. The combination of the instructions will create what's called a program, okay? Now, in order to store that program, we need something called the main memory, okay? The main memory is the RAM itself. Now, most of the of the memories are random access memories, and they are connected using a data bus to the CPU. So the CPU is quickly accessing the data on the RAM. They called random access memory because, the CPU can access the data randomly, and they are a volatile memory used for temporary storage while the program is running, Now, in order to communicate with the computer, we need an input device. So the input device, like a keyboard or like a mouse, a touchpad, a camera, a microphone, okay? So used to collect data from the people, convert it to a digital way, and store it on the secondary storage. Or the secondary storage are either a hard drive itself or a solid state drive. Solid state drive means that it's built using NAND gates technology. So it's faster, it's electrical rather than to be mechanics. Nowadays NVMe hard drives can reach to up to 7,000 megabit per second, So I would like to see the output of my program, or I would like to see the output of the task that I did, the output of writing a document. So I need an output device. The output device, it's used to display your streams. This stream can be like an image, an audio, or any kind of bit stream. And to communicate with other computers, we need the holy internet in order to connect each others together. All right. Okay, so as I mentioned, the CPU will only understand what's called binary, binary instruction, because as I told you, the CPU here is built on billions of transistors, and those transistors will be either on or off according to the code here. So 1 means the transistor has to be on, 0 means it has to be off. Imagine that you have a light bulb, and you're trying to send an SOS. So if you light it, flash it 3 times, that means please come and help me. If you write it, if you done it 5 times, that means you're safe. So there should be a language between us in order to understand how programs are deployed and implemented. In general, how programs are work, they're stored at the RAM, the main memory, and they will be fetched, according. So nowadays you will say, okay, you have a CPU, an Intel CPU with 3 gigahertz. So that means, the speed to fetch the instruction from the RAM is 3,000 giga hertz over a second. After you get the instruction, you need to decode it according to the architecture that used to be to build the CPU. Okay, this is outside the scope of this course, but I'm just explaining it for fun. So if you noticed, the Apple they made something called M1 chip. If you buy a new MacBook Air or MacBook Pro, the architecture used to deploy the CPU is totally different than the Intel and AMD companies. Okay, because they're using like something called Snapdragon CPUs, and like it's based on RISC instruction set rather than the x86. Okay, and after decoding it, it's going to be executed the other cycle, and after it will be executed, you will see the result on the display. Okay, so this is how the program are implemented inside inside the computer itself. Now, so we have covered the hardware part. What about the software part? So the software part is basically an application. That application itself can be, the whole operating system that's hosting your, all the other application, such as Microsoft Windows, Linux, or Mac OS, Big Sur. Can be a computer game, can be the Microsoft Word, or can be, it can be the programming language toolkit that you're using it to write your program. Okay, so that will raise another kind of question. What is a program? So the program is a sequence of instructions. Those instructions, are implemented in a way to solve a problem or to achieve some effects. So, for instance, if I told you to write me a program that will, calculate the root mean square for for a given data, what you have to do is, first of all, you have to try to break that problem into a smaller problem by understanding, okay, what is the main formula for, root mean square? And after that, what are the variables that you need to input? And then after that, you need to have an output and then display that output. So this structured way of thinking is called an algorithm. So the algorithm is a sequence, or it's a recipe for solving a problem. It's a sequence of actions or simple tasks used to accomplish the given task. For instance, if you're calling your mom and she's telling you how to do a pancake, those steps that she's giving you, they're called an algorithm. The implementation of cooking the pancake itself is called the program itself. Okay. So the algorithm actually has been invited, back in the days by a Muslim scientist by the name of Muhammad Musa al-Khwarizmi. He's my grandfather, by the way. And, what he used to do is, it's a way of problem solving. And the way he stipulates solving the problem is by breaking your big problem into smaller problems, trying to find a solution for those smaller problems, and by combining all the solution together, incorporate them all together, you're going to solve that problem itself. Okay? So in this class, what we're going to do, if I give you any exercise, we try to write the algorithm to solve that exercise in our language itself. And that brings us to the next slide, which is what is the difference between formal and natural language. Natural language, like English, those are the languages spoken by the people themselves. The natural language can be ambiguous because it has a lot of metaphors and idioms and ideologies. For instance, if I say somebody is a rat, I don't mean that he's a rat itself. No, he's telling the authorities he's something who's like a snitch or something like that. Formal language, like mathematical equations, as well as chemistry notations, are not ambiguous. Each statement, each word itself, it has an exact meaning, regardless of the context. In natural language, based on the context itself, a word can have multiple synonyms. When it comes to programming language, in a programming language are parts of the formal languages, okay? Okay, so why do we need to understand programming language? We need to understand programming language because we need to, to communicate with the hardware components themselves, okay? And to understand the programming language, we have to go over, the basic rules and, structures that made that language itself. For instance, if you want to learn English, the first thing you have to learn is what? The alphabetic characters and the numerical, and then after that you need to combine them to create words. And this is what we're gonna do. First, I'm gonna introduce you to the type of variables in Python, and then after that, how we can combine those variables to create what's called a function. And then you can create your own data type, which is called a class. And this is like later on, but I'm just, I'm just trying to give you a brief of what is what do I mean by a programming language. In general, programming language can be classified into two main categories. The first category is high-level programming language. Examples of that are the Java, the Python, the R tool now used for data scientists. The main advantages of these languages, they are their structures in a way that is easier for the for the developers to write them, and easier for the reader of the code to understand it, because they're mainly use English notation, and they use it's basically they can run any mathematical equation as is. The disadvantage of those high-level programming language is they need to be translated to what? To a machine learning or a ones and zeros, simply a version, so the CPU can run it. You remember that we need to store it first at a secondary storage, and fetch it to the RAM, and after that fetch it to the CPU. So they have to be what? They have to be translated. In order to be translated, we need something called a compiler and an interpreter. And then the next slide, I'm going to explain the difference between both of them. Okay, so high-level languages are the language used by us as a human in order to communicate and build programs using the computers. Now, when it comes to the other type is the low-level programming language. There are two types. There are assembly and machine, machines, and both of them, one are using the hexa notation, hexadecimal notation, and the others are using ones and zero. The most advantage of the machine learning is you don't need to compile, you don't need to translate them, so you're saving that part of the time to execute them. They can be directly loaded to the to the CPU, as well as you will have a fast output. But the thing is, you cannot understand them, because it's it's a cipher, it's ones and zeros. So how you can understand them, And it's used by few special applications that use for encryption and security purpose. All right. Okay. So what is the difference between interpreting and compiling? Okay. When it comes to translating a program written in Python or in any high-level language, that program itself will be written in something called the source code. So when we write print hello world, that's the source code. Now, after that, we have to, to convert it into a binary version to be executed using the CPU that are built using semiconductors transistors, which are just switches on and off, ones and zeros. So when it comes to the compilers convert the high level language source code into a machine language, and it's like, it translates the whole program at any time in one jump, the interpreter, what will do is will execute the high-level program directly, and each instruction will be converted to what? To to a machine learning, to a machine language, and will be what? Will be loaded to the CPU, so you will avoid the delay of the compilation. But in general, interpreted programs run slower than compiled programs if you would like to re-execute them multiple times. Okay. Now, when it comes to the Python, Python itself, we used the interpreter, whether it's the IDLE or the Google Colab or the Jupyter, because each statement we write, each piece of code we write is going to be like translated line by line to a binary format and then executed. Okay. So this is a schematic figure of how programs are executed on the CPU. So first, you see that you write the program itself. This is a snip of a code written in Python. So hello earthing, print hello earthing. Now hello earthing will be translated using the interpreter, which is the interactive development environment program, and it will be converted to ones and zeros, and then the CPU can be able to understand it and execute it immediately. All right. Okay, so we were talking about multiple high-level languages, but we're gonna focus on Python. So who created Python? Python has been created by this dude. Okay, he is like a Dutch scientist by the name of Gaudio van Rossum. He was working at the National Research Institute for Mathematics and Computer Science in Amsterdam, and he released it publicly in 1991. So it's a new, it's a kind of new language compared to the C, which was invented in the 1960s. It becomes one of the most popular programming language because it's, as you can see, if you have taken GNG, if you've taken C, C is a nightmare compared to the Python. Python is more it's exactly telling working with Siri, working with Siri or Google Assistants or Alexa. So you just need to to understand the syntax to execute an instructions, and that's it. And nowadays, because you see Netflix, they're using machine learning in order to display the content relevant to the movies that you have watched, building a recommendatory systems, and because it's easy to be implemented and deployed, it's now commonly used by big companies. Okay. And the fun fact, when we see Python, it will come to our mind that it has been named by the snake Python. However, no, the answer itself, when it comes how Python has been named, it has been named after a British sketch comedy from the 70s called, the 70th Monty Python Flying Circus. Okay. And what's good about Python is not a proprietary language. It's a free open software and has a big community-based development model. So what does that mean? That means in the next lectures, can see that you can import a library, and that library will do all the mathematical functions that you need. Okay. Now, let me just, focus more about the main objective of this course. The main objective of this course is about computational thinking, not about measuring how are you professional in Python itself. Okay. And why we choose Python? Because as I mentioned, Python is used in many universities as an introductory courses. As a matter of fact, in Canada here, they are teaching Python at the high schools. I don't know in other countries. And now it's widely used by like a lot of scientific institutions. And, because it's fast to be deployed and implemented, it's adopted in multiple embedded platforms. Okay. And the funny thing, guys, once you learn the structure of one programming language, it's the same. Once I'm going to introduce you to what's called function development and object-oriented development, it's the same, regardless if you're going to do it on Python, C++, or in Java. All right. Now, as I told you before, there are two major versions of Python, Python 2 and Python 3. Python 2, they're still using it for data science and big data analysis and for machine learning. However, we are gonna use Python 3. And Python 3 has been released to rectify the flaws in the and the mistakes in in Python 2. The bugs in Python 2. However, unfortunately, they are not backward compatible. So, some instructions and the syntax of the instructions in Python 3 is different than Python 2. If you would like to, more to know the difference between Python 2 and Python 3, which are outside the scope of this course, you can go to this link and consult that. Now, how are we going to use Python? We're going to click on this link, download the idle, okay, the idle itself. And after that, we will be able to run our first program. So to sum up everything, computer science is different than computer and mathematical engineering. We teach programming to solve, to understand computational thinking, and to understand how to solve problems using computer, how to decompose a problem into smaller problems and finding a way to solve those problems and combining them together. You have to distinguish that, the computer doesn't think doesn't think at all. Whatever you feed them, they will execute it, So you need to distinguish between your thinking and how and what's capable to be done using a specific programming language. That's why we need, I introduced you to the algorithms, which is the recipe to write to write the problems into a pseudocode that can be understood by us as a human, and then we're gonna convert it to an equivalent program. And as I told you, 30 years ago, a solution for all the professors at the university, they didn't do programming. They all the PhDs and masters used to be on proposing a mathematical model to solve a specific problems itself. But now everything is computerized. Okay. Now, Now, so to start the first program, what you have to do, guys, is there is multiple interpreter for Python. Okay. Now, if I'm teaching the course by myself, I'm going to use Google Colab. Google Colab is, it's like Google Docs. It's going to give you a virtual machine, has a Python configured there, and you can execute the instruction there. I'm going to show you. You know what? Okay, I will show you what is the Google Colab itself. Google Colab. So if you search in Google Colab and say here, print hello ITI 1100C, and then execute it. It prints hello ITI 1100C. Now, what I can do, like using like I can create another cell and say that I want to use Python to, like find the power of 2, like 2 power. Okay, where is power here in my, yes, 2 to the power, 8. What's 2 to the power 8, guys? 2 to the power 8. Can anybody, like in the chat, say what's 2 to the power 8? It's 256. Okay, guys, you need to help me and to be interacted with me. So I will help you at the exams, okay? Okay, 2 to the power 6. Okay, let's do another thing. Okay, 5 minus 3. 2. Okay, now this is one way of like, writing a Python program. The other way is downloading the, like going to say like this, download Python. And what you have to do is download the latest, download Python 3.9.7. So after downloading it, just go, on the executable file and install it. Okay, I'm not gonna install it because I'm working on Python 2. Okay, so I have it here. Okay, so let's go here and let's make it more better for you guys to, like, let's go to option, configure idle. Okay, increase the, let's increase that. Let's make it more the theme, new color. Okay, Python keywords and apply. Perfect. And let's say that here I want to do 2 to the power 8. Why it's giving me 2 to the power 8, 10? I think 2 to the power 8 is 256. Okay, so let's say that I want to print. As you can see, print is a function itself. That was, it turns the color, and print is, so this is how we can like write our first program, in Python. Now, as you can see, like I'm doing it using the command shell itself. Yeah, however, we can use the this is the interactive mode, which is whenever I write a statement, I get the answer right away. However, we can do multiple things. Like I can go back here right there, and I can start new file, and at the new file here I can say A equal to 5, B equal to 10, and C equal to 5 to A multiplied by B, and then I would like to print C. Print, sorry, B. Okay. And then after that, what I have to do is to save it. Okay. Once I save it, it has the like a PY extension. And let's save it and anything, you know, like test. Okay. Test. Yes. Save. All right. And after that, I have to hit run. Run module. Okay. So it gives me 50. Or I can say print C equal and a comma. And then run it again. Yes. It's print C equal 250. Okay. So that's it for today, guys. What I'm gonna do now is I'm gonna go to Brightspace and show you some. Okay, let's go to Brightspace. Okay, that is your Brightspace, guys. Let's view it as a student. Okay, so overview. It will display your name. Okay, I'm not, you know, like I'm using like an HTML. That's why it's showing you your name. And if you go to Python resources, this is the book I've told you about it, and this is the Python visualizer that we're gonna use it like later on. I want you now to click on online Coursera course and to enroll. Okay, you can enroll for free. Like it has, as you can see, 4.7 out of 5 rating, and it's given by the University of Toronto. So it's a very useful and, you know, like recommended complimentary course to watch. And after that, at the middle of the course, what we have to do is you're going to enroll at Learn to Program Crafting Quality Code. So the first course is to understand the basic. The secondly is how to write, like how to become a developer itself. Okay. Now, if you go to the logistics, now for the book itself, I've shown you here exactly what is the text book, what kind of what of the chapters that you need to like to read. So, for instance, chapter 1 is voluntary. Chapter 2, you have to read it all, and this is like until the end of the semesters. If you would like to ask me some questions, this will be filled like whenever I have the whole team of the TAs. If you have to ask me questions, you know, you can ask me here, ask the prof here. Okay. Now, let's stop sharing. If you have any questions, raise your hand, and I'm gonna like answer you. Unmute you and answer you. All right. Do you have any questions? Okay, unmute.
So about Stack Overflow, are we allowed to search our questions up on Stack Overflow and use that as a reference? Does that count as like plagiarizing?
Oh, yeah, you can use Stack Overflow and Reddit. Yeah, you can. Okay. Any other questions? No, the textbook is not mandatory. It's recommended, not mandatory. Baby, no one could see your search history if you search the problems. Lul. What's this? Yes, the lab will be due. Oh, yeah. You're right. The power is, yeah. I've been like thinking about, you know, C++. So your colleague is, you know, he corrected me. So 2 to the power, it is done like this. This is, we'll cover it like later on. 2 to the power 8 is 256 like this. Thank you so much. You can use it. Yeah. Yes. He's not my grandfather. I'm joking. We'll see about that. The final project, we'll see about that. Okay, we'll see how it will be the progress of you guys. And if you're not doing well, I'm gonna announce some kind of projects. It will be on Brightspace, but the link for the lab itself for the Zoom it's gonna be posted on Brightspace. Can I use ripple.it? You can use whatever you want, but you have to, make sure that you're exporting the file as .py, because the Google Colab, you see it. It's it's gonna save it as a Python textbook. Yes, yes. The slides will be posted on Brightspace, of course. Well, listen. When it comes to Caitlin, you will succeed in this course regardless of any skills if you do not have any coding background, because we're gonna start from scratch, acquire the knowledge step by step, and by practicing, you will get a straight A. Okay? No, there will be no conflict. Yes. On Brightspace. Okay, so let's unmute some people. Okay, Majid, you can ask me. Majid.
For Monday's lab, are we going to learn something new, or are we just going to practice how to submit the assignment?
Yeah, that's it.
Okay, thank you.
Okay. You can ask me, Sergeant.
Okay. I would just like to ask, will there be any group-based project or something like that?
They just propose it, so I'm gonna think about it. You know what I mean? No, yeah. When it comes to the assignments labs individually, there's no groups.
Okay.
We'll see about that.
So
okay.
Yeah, for her until the next lecture, is there any work we should be focusing on?
Just read my slides again. That's it. Install IDLE, or get familiar with any kind of interpreter, and that's it.
All right, thank you.
Enroll at the courses at Coursera and try to study the first week module.
Okay.
Okay.
Hello. So I want to know if it is good to use Python 3.7 because I already have 3.7, or is there any sort of major change?
No. There is no major change.
All right. Thank you.
As you saw, I'm using here 3.4 because I have a Conda here. Okay, the labs are based on the IDLE interpreter. Okay, but you're allowed to use whatever interpreter you need. Okay, guys, did you understand the lecture today? Was it smooth? Was it clear? Okay, that's a good thing. That's a good sign. All right, do you have any questions for me, guys? What's the question?
Hello, I would just want to know how to cite code in a way that's acceptable for this class, because I don't want to get struck with any plagiarism stuff and stuff like that.
Okay, we're gonna introduce you to the comment, and you can comment that at your code. Okay? Okay, other question?
Professor, is PPT available on the Brightspace?
Video will be available on Brightspace and as well as the slides itself.
Okay, thank you. And my question is pop-up quizzes appear on lecture time?
Yes, pop-up quizzes on lecture time.
Okay, thank you.
Most probably the assignments will be like the sections with the Professor Vida, but sometimes she grilled her students, you know, with hard questions. But I'm gonna do it, you know, I'm gonna like make sure that most of my students, they can pass the assignments, and then like, you know, 20% is the challenging questions. Okay, so it's not guaranteed that I'm gonna follow here. Easier here.
Hello?
Yeah.
Hi. So I have a little bit of like prior knowledge of Python. What is the most complicated thing we'll be doing? Just like so I can kind of gauge how much I'll be learning.
Polymorphism.
I don't know what that means, so that's a good sign. All right.
Okay. Okay, any other questions, guys, from me? Yeah, I just want to like bring I just want to bring to your attention that sometimes, you know, I'll be traveling, so like I'll post the lectures in a synchronous way, which is like I will record the lectures and post it there. But like, you know, every week we should have like, you know, like every week or second week we'll have a live lectures in case you have questions for the thing that I've posted. Okay, guys. Some of the students, they want to go for the second class. Well, I will see you like on Tuesday, okay? Okay, have a good day, guys. Enjoy your day and stay safe.